Okay, for the first part of the session of the lecture today, what I'm going to do is we're going to discuss first uh, the last exercise on Shapley-Shubik value. Then after that, we're going to continue our chapter 6. Okay. So everyone can see my screen, and I think you also have the the question in the WhatsApp last week. Okay. So I hope everyone already done this one after watching the video. That's the purpose that I'm giving you the questions. So today I'll call some of you to discuss the answer. Okay. A parliament is made up of 4 political parties, A, B, C, and D, which have 45, 25, 15, and 15 representative respectively. They are to vote on whether to pass $100 million spending bill and how much of this amount should be controlled by each other of the party. A majority, a majority vote, that is minimum 51 votes, is required in order to pass any legalizations. And if the bill does not approve, then every party gets zero to spend. Okay, that is the questions. So the first one I'm going to call Muhammad Midyaf. Are you there?
Good morning, doctor.
Good morning, Midyaf. Okay, for this question, you already go through the video, right?
Yes, but I didn't done yet, doctor.
No worries. Then answer the question I'm asking now. Okay.
Okay.
What means quota?
But I think it's the limit.
The
The like the vote on whether to pass 100 million spending bill when a party like A have
okay.
45 vote. When it didn't reach the quota, then we have to continue uh include the B, and if it reach the quota, then we stop right there.
Okay. Good. So here, what means the quota? Is simple. Quota is the minimum required vote, which is 51. Understand or not?
Oh, okay.
Okay. So quota is 51. The minimum vote required to pass the bill. Okay. So next, Zulaika, are you there?
Yes, doctor.
Good morning, Zulaika.
Morning, doctor.
What is the percentage of the quota?
51%.
Okay, good. How you get 51%?
51 over 100 times 100%.
Yeah. Is it hard?
No.
Good. Thank you. Okay, for the third one, how many players are there? Definitely it is easy. A, B, C, and D. So it means that we have 4 players. Okay. Yep, Sini, good morning.
Good morning, doctor.
Is there any dictator? What means dictator, by the way? Yep, Sini.
I think detector is a voter whose weight is greater than or equal to the quota.
Okay, good. Correct. Correct. So in this case, if is there any dictator?
No,
No. Why?
because the minimum vote is 51 and the largest vote for the player is 45, which is which is less than the quota.
Thank you so much, girl.
Okay.
Okay, so next is, let me call Chen Yi. Good morning.
Good morning, doctor.
Jenny, is there anyone called dummy player? What means of dummy player?
I think no.
No. What means dummy player?
The dummy player is the player that will not affect whether the situation is past the button or not.
Good, good. Thank you, boy. Okay. Finally, find the Shapley-Shubik power distributions. Already teach all of you how we should get that Shapley power distribution for every player, while we just do the combination of A, B, C, and D, and we need to know when the correlation will be achieved and enough for passing the bill. So I'm going to call someone. Chazini,
Yes, doctor.
morning, girl.
Yeah.
Chazini, did you already done this one?
No, I did the wrong question.
Oh, you did the wrong question. Okay, never mind. Thank you.
Yeah, thank you, sir.
Okay, I will give around let's say I give around 6 to 7 minutes. All of you, please try to do the Shapley-Shubik power distributions for this question. Then I'll call someone on 10. Now it's 10:14. I'll give 7 minutes. It's easy. It's easy. Try to do. Thank you.
Doctor,
Yes. Can you talk louder, please? Chance Pay.
can you hear me now?
Yeah. Clear.
I think you have leveled the discussion for question E, the veto power.
The question number. No. Oh, okay.
E, the veto power.
Yeah. Thank you. Chance Pay, can you answer for this question? Does anyone has a veto power?
No.
What is veto power?
Veto power is a single voter that has, like, without that player, then the issue cannot pass without his or her vote.
Correct. Okay, let me call someone. Example, let me add a few things about veto power. In this case, we have A is 45, B is 25, C is 15 and 15. Although A look like veto power, but it does not, because if A is not in the picture of coalitions, B, C, D total together still can achieve 51%. That's why we does not call this the player A as a veto power. Okay, that's why these questions does not have veto power. Okay, let me continue. Ho Yung Look, good morning. Okay, what will be the A Shapley-Shubik distribution?
You mean the power of A?
The percentage of the coalitions. It means how many times A can be selected in coalitions.
12 times.
12 times. So 12 over how many? You have 4 player. 4 factorial, it means 36, is it?
12 over 24.
12 over 24. Or so it means the 100%, right? 100%, right? 12 over 12, right? Girl?
Yeah.
Yeah, because A have the more higher woods, so it can collaborate or correlate with any of other player, because they just need another 6 votes to get the minimum majority votes. Okay, so thank you, Ho Yung Look.
Thank you, doctor.
Okay, so next, let me call Nazran, Muhammad Nazran Ali. Good morning.
Yes, good morning, doctor.
Okay, what will be the Shapley-Shubik power distribution or percentage for player B?
Doktor, saya masih kira lagi, Doktor.
Masih kira lagi. Okey,
Ya,
tak apa,
ya.
tak apa. Teruskan kira. Terima kasih. Lokmano? Lokmano?
Mak dia panggil, Doktor.
Oh, mak dia panggil. Okey, okey. Terima kasih, Dik. Siapa yang bagi tahu mak dia panggil?
Rafiq.
Rafiq. Good morning.
Ya, good morning, Doktor.
Apa percentage untuk B?
Saya pun tengah kira, Doktor.
Belum kira. Okey, thank you. Tolong kira. Go, Chaiwan. Good morning.
Morning, Doctor.
Did you already done for this question for player B?
Yes.
What will be the value?
4/24.
4/24. Okay, so what do you get? 4/24 equivalent to?
16.67%.
Okay, thank you so much, girl. Guan Liang Yi. Liang Yi Li. Good morning.
Morning, Doctor.
What will be the player C?
Player C has 4/24.
4/24. It means equivalent to?
16.67%.
So D also should have the same value, right?
Yeah.
Okay, thank you so much. Good. Okay, let's do another exercise before we wrap up the lecture. Okay, try to do this question and do remember all of these questions actually example question from past final exam and also midterm from game theory in our class in game theory. Okay, so please do this question and I will give around 10 minutes. Okay, 10 minutes, then I will come back to asking or to discuss it. Thank you. I hope all of you have a rough idea what's going on. Player A, B, and C collaborate on a test with 10 questions. A knows that answer to question A knows the answer to questions 1, 2, 3, 4, 5, and 6. We know the answer to question 3, 4, and 5. And C knows the answers to the questions 5, 6, 7, and 8. They will get $1 for each correct answer. So they will get $8 to split. Find the Shapley value for each player. This is I think I took this question from UCLA final exams. Okay, UCLA final exams. Okay, let me call someone. This is considered a very easy question. Okay, what's the first step that we should do for this question, girl? Or what do you understand from this question?
Find the permutation.
Okay, good. Find the permutations. So we get how many players here?
3.
Good. So what the order should be? How many order should be? 3 times 2 times 1, right? 3 factorial.
Yes.
So we get how many order?
6.
Good. So thank you so much.
Thank you.
So we should get 6 order because we have 3 player, 3 factorial is 3 times 2 times 1 equivalent to 6. Okay, we know that player A only can answer question 1, 2, 3, 4, 5, 6. They did not know to answer 7, 8, 9, and 10. Player B only know how to answer 3, 4, 5. They did not know the answer for another 6 questions, 7 questions. And for C, we know they did not know to answer another 6 questions. Okay, so they already told that they will get $1 for each correct answer. So that total together they will have $8. $8. Okay, to split. Find the Shapley value. So the first one, it is easy to see what all the coalitions are wood. So this problem is pretty easy. So we just need to construct the table like we usually do. Okay, like we usually do. Okay, so let's see one example. One example, let's see for A, B, and C. We know that A can answer 6 questions. That's why you put for the ABC, the first coalition will be 6. Okay. For B, it will be 0. Why it will be 0? Nazran? Iril?
Yeah, doctor.
Okay, good morning, Iril.
Morning.
Ariel, why the second, when the first coalitions, A, we know they can answer 6 questions, right? So they
Yeah.
will get 6 ringgit, correct or not?
Yeah.
Why for the B is 0?
Because even though B know the answer for 3, 4, 5, A already know. So technically B has no value. The 3,
Very
4,
good.
5.
You understand, right?
Yeah.
And C is 2. Also, you know why, right?
Yeah, because 7 and 8.
Very good. Okay. Thank you so much, Ariel.
Okay.
Okay. Next, I'm going to call Ching Kahoy.
Yes, doctor.
Morning, Ching Kahoy.
Morning, doctor.
Okay. Let's say now we look at the A, C, B. What will be the value?
ACB.
Ah.
For the marginal contribution of A, it is 6.
Okay.
For B, it is 0. For C is 2.
C is 2. So it's same, right?
Yeah.
Thank you. Thank you, boy.
Thank you.
Lukmanul, are you there? Hi, morning, Lukmanul. What will be the marginal contribution for BAC? What? C is 2, B is 6. How we get B is 6? A is 6, B is 0. The order now is BAC. So BAC, no, you will get, you need to understand the marginal contribution for B. So for B, okay. Well, you will get 3, 3, and 2. Why 3, 3, and 2? Lukmanul? Yep. Okay, never mind. Let's look from other answer. Thank you, Lukmanul. So let me call Jason. Jason Lee, Chi Hong, Zi
Yes,
Hong.
doctor.
Morning, Jason.
Morning, doctor.
Did you get 332?
Yes.
Can you talk louder a bit, girl, boy?
Yes, I get 332 for BAC.
Why you get 332? Can you explain to us?
For the marginal of B, I get is 3. Then for A is AB minus A, so you get 3. And for the C is ABC minus for the AB, so you get 2.
Yeah, because now for B question, we only can answer 3, correct or not?
Yes.
Okay, then you get 3, 3, and 2. Can you understand or not, Lukmanul? Lukmanul? Easy, right? Because B can answer 3, 4, 5. Definitely A can answer only 1, 2, and 6. Correct or not? Understand, huh? Okay. So thank you very much. No Shahira?
Yes, doctor.
Macam mana BCA boleh dapat 2, 3, 3?
First B will answer 3, 4, 5. Then
Okay.
C will left with 6, 7, 8.
Hmm.
And A will left with 1 and 2.
Okay.
So each of the distribution is A2, B3, and C3.
Okay, good. Thank you very much, girl. So total together, when you add on marginal contribution A, B, and C, you will get 23 over 6, 8 over 6, and 17 over 6. So this is will be the Shapley value when they are correlate with for marginal contribution A, B, and C. Anyone to want to ask me anything before we can continue with another question? Don't worry, I will upload these answers and questions after the first half of the lecture. Let's try to do this question, the last question on Shapley value, before we can wrap up the lecture. Let Wi be a number, okay, be a number associated with player I equals to 1, 2, and 3. Suppose a coalition S for that particular subset of that 3 player. We have the value Vs equivalent summation from summation I under S Wi square. Find the Shapley values for x1, x2, x3 for the player when W1 equals to 2, W2 equals to 3, and W3 equals to -1. Don't do question number B. Just try to do question number A first. I will give you another 5 minutes. No, Natasha?
Yes, doctor.
Good morning, Natasha.
Good morning.
Okay, Natasha, what we should do for the first step for this question?
Find the permutation.
Okay.
So we'll have 6.
Okay. Let's say the first order 1 to 3. What will be the value for marginal contribution of player A?
2.
2. For this case, when marginal contribution for A, okay. First of all, what you should do, you should calculate first the value. Okay. Let's say if V1, you just need to use that value 2 square. Correct? Hello?
Yeah.
Wait, Natasha. Wait, huh? Sorry, Natasha. Okay, let's continue. Okay, for this question, for part A, we have empty set equals to 0. Correct?
Yes.
V1 equals to 4. Correct?
Yeah.
Hello, Natasha?
Yes.
Macam mana tadi dapat 2?
Oh, lupa nak kuasa 2.
Boleh?
Boleh, faham.
So V2 we get 9 and V3 we get 1. Why V3 we get 1? Because W3 is -1. -1 square you get 1.
Yeah.
Thank you, girl.
Okay.
No Kuratu?
Yes, Doctor.
Good morning.
Good morning, Doctor.
Apa pendapat untuk V12 ke? Tadi kita tahu
V12.
Okay. Apa
25.
25. Okay, good. V13?
V13 4.
Berapa?
4.
Wow, okay. Dan V123? Sorry, V23?
V23 4.
4. V123?
V123 16. 16.
Okay, so let's look. V12 25, V131, V234, and V123 16. Okay. Next, after you use your Shapley value, you will get 8, 12, and -4. You can always check. If you did not get that one, let me know. Okay. The good thing, the best thing of this question is question number B. Because in question number B, they ask find a simple formula for xi. it's not for one player, two player, or three player, but for xi player in terms of W1, W2, and W3. They also give us the hint, try it for a two-player version for the first game. Okay, so I also already give you the part two answer. Please go through, but if you did not understand it, no worries. We can discuss it on next Monday. So what I'm going to do now, I'm going to upload this one in the group. Then we will continue with second lecture on incomplete statistic game. Okay, we will start sharp at 11 o'clock. Okay, let's continue. Okay, by the way, don't forget that on 3rd next week, Friday, we will have our test. Is it okay for all of you to have the test on next week, Friday, from 10:30 to 12 o'clock, 1.5 hours? Or did any of you have any problem? We can discuss now. And also don't forget, we have the next research talk by Associate Professor Mijanur Rahman from Maulana Science University, Bangladesh. He actually is my student, my previous student, my PhD student. Recently, he just received associate professor, and he's giving talk on game theory in using Penang CCTV video and contributions to big data analytics. Okay, towards big data analytics, and I'm going to do it on Tuesday, 30th, on 30th of November, our second talk. Okay, so I think everyone should be okay, right? For the questions, there will be around 3 questions. Each will be contribute around 7, 8, and 8 marks for the final. And the question will be covered from the first lecture until the 5th lecture, which is what we finished until now. Okay, and for and for final, it will cover from the first lecture until the end lecture. Okay. Okay, let me share our
Doctor,
presentation. Yeah.
sorry to interrupt. So that means the first to the fifth is until Shapley, Doctor.
Yep, until Shapley.
Okay, Doctor, thank you.
Okay, thank you. Okay, let me share the screen. Okay, all of you can see my slide, right? Thank you, Lokmano. Okay, let's move to a new topic, which will be more exciting, more complex, more Nobel Prize, and more high thinking order. So starting from now, we will look both of decision tree and also in matrix form. And here I will start to teach you how to convert the decision tree back into the matrix. Okay. A lot of the games involve on statistics games. And before that, we need to understand one thing. In here, our sorry. In here, what I do, I put in the title that incomplete information. Do remember, we will start to look not only in the games, is it playing once or repeated, not only regarding are we playing sequentials or simultaneous, not only looking at is it we will have one equilibria, multiple equilibria, or mixed equilibria, but we also will start to look about information. Information is the crucial things in the any games or strategic decisions that will make by other individual, by other firms, or uh, uh, by other organizations, so that they can still sustain in that particular field. And when you are saying information, we can divide the information into 4 types. One is complete information. The second one will be incomplete information. The third one will be the perfect information. The fourth one, we will look at imperfect information. What is the difference between incomplete and imperfect? Or what between of the complete and perfect? Can anyone let me know? I can give you 10 ringgit. And don't remember, I still did not pay yet for student. I still remember. I already jot down. Don't worry. Okay. Anyone want to try? 10 ringgit. Vanessa, are you there? Good morning.
Good morning, doctor.
What is different between perfect? Because you are from economics, right? Max with econs or statistics?
Maths and econs.
Yeah, definitely you should learn about this one. What is different between complete and perfect?
Complete is like they can observe the other player, and perfect is that not too sure.
Not sure. Okay, never mind. Thank you, Vanessa.
Sorry, doctor.
No worries, no worries, no worries. Okay, let me call another person. Norai Nabila, are you there?
Yes, doctor.
Good morning.
Good morning, doctor.
You are also from Mexican, right?
Yes.
What is the difference between perfect and complete?
I'm not sure, doctor.
Okay, Nur Alia, Fakira?
Doctor.
Alia?
I think.
Hello Alia, kau boleh cakap kau sikit tak? Tak dengar.
Hello.
Okay.
Okay. Um, I'm not really sure, but I think complete. That's mean it's something that we can do. It's finished, but not necessarily done well. But perfect. It is finished and done well.
Good. How you can relate this one into games?
I'm not sure, doctor.
Okay, thank you. Okay, so we have, I will teach you what the games that call complete and perfect. Complete means you know about your opponent. You know their strategy, but you did not know when they will use that particular strategy. That's called complete information. But when you're talking about perfect information, you not only know about your opponent, you not only know their strategy, but also you know when they will use that particular strategy. Okay, so that's called perfect. Don't worry, in this lecture, especially on statistic games and repeated game, we will learn the 4 different set of information. That's why people always mention information is the wealth. Okay, it's true. Without information, you cannot sustain in the industry. And from here, actually, we start to get a lot of Nobel Prize winner. So let me continue. Before that, let's recap back important definition. Equilibrium. What means of equilibrium? Equilibrium in a pure and mixed strategy called as balance in game. It means we just look at the between of the player strategy. But when we go to the Nash, Sir Nash mentioned that is a concept in non-cooperative game for for 2 or more players, and players assume to know the equilibrium of opponent strategy and no gain if changing only his own strategy. They need to change both of the strategy, opponent and also them. So then they will have some gain. Here we will look at 2 types of games. First, static versus dynamic. Static means it only play once, while dynamic will play. Example of static games we call prisoner dilemma. Prisoner dilemma. And dynamic means game is played in multiple rounds. Example, paper, rock, scissors. If paper, rock, scissors only plays one, we call that one a static game. But if we repeated play in multiple rounds is called dynamic games. What's the good thing of static and dynamic? Can anyone? No, Shahida?
Yes, doctor.
Now, Shahida, what do you understand regarding static and dynamic, and what is good for static and for dynamic games?
I'm not so sure, doctor.
Thank you. No worries. For static game, when you only play once, you does not what we does not have a full information, or we call incomplete information, because it's only play once and we did not know what will happen in the long term. But when you start to play in multiple rounds, what will happen? You can figure the the strategy that used by your opponent. And when you know the strategy used by opponent, when it play of multiple rounds, we know that higher chances that you can predict the strategy, and also higher chances they can correlate with each other. So it means that multiple round auctions chess game. Here what we're going to do this for this semester, we also will play some online chess game for each together to understand about dynamic games, and also we look on the how auction we play. Here, most interesting thing, we look on the auction because we look on the first seal bid, second seal bid, English auction, Japanese auction, and Holland auctions, and also another auction called Dutch auction. I will teach you what the difference between the 6 auctions, and definitely will be one question from that 6 auction in your finals. It will be a very interesting game. Now we look at the complete versus incomplete information. Complete info means player know each other payoff. Knowing each other payoff does not mean that they know each other's strategy. They only know the value of the coalition. Example for prisoner dilemma. Incomplete info, other player payoff are not known. It does not mean that they did not know about the other strategy. Okay, like a seal auction. Seal auction means it's called a first bid auction or called as English auction, where you cannot know your opponent does not know your value. And in this particular auction, the highest bidder will win the bidding. But do remember, you also need to look about the winning curse. Winning curse here means you need to know if although you win, is it worth of winning or not? Worth of winning or not? Okay, we will look in detail when we are learn about incomplete information. And here we have, like I mentioned just now, we have we already learned about non-cooperative and cooperative. We're going to learn about static and dynamic. We also already learned about strategic form and extensive form. We will learn this one, perfect or imperfect, in coming lecture. And currently we are doing on complete and incomplete. I will start with incomplete first, then we go to the complete, because complete quite easy compared to incomplete. And here, perfect information means that each player know the identity of the player, and for each of them, the payoff resulting of the strategy. While for complete, each player can only observe the action of each other player, but they cannot identify. That's why when we are looking at the Nash equilibrium, previously we know we have a problem when we play only using pure strategy. Next, Nash, when we have a complete information and we have a simultaneous players or strategy, we always can use Nash equilibrium, and we can always get the information from Nash equilibrium. But when you start to learn about incomplete information and when you're playing simultaneously, we will start to look at another form of equilibrium called Bayesian's rules. Bayesian's rules. In this Bayesian's rule, we will extend this Bayesian's rules using Harnashi transformation to understand how to get sub-perfect equilibrium. Okay, that we will look on the complete information. So today what we're going to look at basically on the Bayesian Nash equilibrium. Okay, I think most of you already learned what means Bayesian. Bayesian is a probability either happen or not happen. P 1 minus P. But the good thing in the games, in our games, when you are looking at the incomplete information, when you are playing Bayesian Nash equilibrium, and definitely you only can play Bayesian Nash equilibrium, I will let you know why. You will have a nature. You will have a nature, will divide your probability, will assume your probability of a particular probability. And we use this probability, this probability will be always changed according to the field or to the experiment. Okay, so when you have a nature, nature will divide the rules of the games. That's why in order, when you already have a nature, you need to use Bayesians. Okay, and one of the important and very famous games using Bayesian Nash equilibrium is signaling games. Signaling games. And do remember, signaling games still being used in many physics or optical research. Optical research. And comparison, if you still remember, we say Nash equilibrium is non-cooperative and we can just gain if changing the opponent and your own strategy. But In Bayesian, the good thing is you will have a type. A type here means a nature. And 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 in this type, we will have a belief system. That's why it's totally different with Nash equilibrium and actually very good when we want to solve a very complicated problem. That's why I always love to teach from incomplete information. From incomplete information. Issue with Nash equilibrium. Impossible to implement by matrix. Yeah, you can do for 2 by 2 or at maximum 3 by 3 or 4 by 4. But do remember, if you start to have, when you start to have a nature, when you start to have a type, and you start to have a very large layer, it is very impossible to implement in bi-matrix form. Why are called bi-matrix? Because in this particular lecture, we will look at the nature. Biometrics representation. Layers are uncertain of the action that will be played or the opponent player. That's why it's called incomplete information. There is a control. In this game, we have a control called as the nature. And finally, in here, we'll have a type of strategy due to the incomplete of information. That's why there is some issue if we want to still solve it with Nash equilibrium, which it does not show the magnitude of the game. Although Sir Nash managed to prove the weakness of 200 years theory, do remember, people always come with a better product or better theorems or better strategy. And the good thing is actually proposed by John Harnashi. Okay, the John Harnashi games with incomplete information played by Bayesians. This is published under management science, are very well known for game theory. Okay, and actually they managed to produce to play for they have three parts. They have three parts of the paper. This is the first one on the basic model. We will look on the second part and third part when we are looking on subperfect Nash equilibrium. Definitely, we're going to use his paper to prove the method, as what I do for the Harnashi and Kakutani theorem. And here we have static games with incomplete information. I already mentioned what means of complete or incomplete. And metric games will have a unique pair of metrics where each player type match up. And I love to give a reason or well-known motivating problem, still not solved until recently. Recently, they have solved two issues, and we still can implement our game theory to solve the issue. The first one is indirect material procurement at Intel. Procurement means the process, and it's involved with scheduling and also inventory. Okay, the problem still motivated a lot of researchers. Direct material procurement at GM. GM is a well-known company in US. Network formations problem at GM, Infosys, and IBM. They have a problem of network formation, but currently they managed to solve for IBM and Infosys and sponsored search auctions. Very well-known problem. We will look at it, and if we have time, we will try to look at it. Not only looking at it, we also will play on it. So when you are coming after the midterm test, I will teach you what your first assignment one will be according to the complete and incomplete information. And do remember on Bayesian's game. So we will have a Bayesian is a strategic form with incomplete information. It consists of a set of players and equals to 1 to n for each I subset to n. N means the number of player, I is the type of player, not type, it means player I. An action set, you have a lot of action set. A type, you only have a 2 type of set or maybe 3 type of set. We will look what type of the set is. A probability function, a payoff function. We need to use all this information to solve on Bayesian-Nash equilibrium. And here, do remember we also can do on the Bayesian game to find in the pure and mixed strategy. I'm not going into the detail. We will look when we start to have example. Okay? A Bayesian equilibrium of a Bayesian game is a mixed strategy profile such that for every player and every type we will have our argument max with a summation of probability of the payoff. Okay, of the payoff. And Bayesian equilibrium is one of the mixed strategy profile, which maximize the each player's expected payoff for each type. This equilibrium is the solution for the Bayesian game. This equilibrium means that the best response. When you go to the complete information, we will start to learn about best response. Let's look on this example. Example 1b of an incomplete information. This is about the prisoner dilemma. Have two types. One we call selfish. The second one we call nice. Player, it depends on which player. Now we no need to depend on player 1 or player 2 in order to determine the type. It can be player 1, it can be player 2. Okay, it can be player 1 and player 2. And if in this case, let's say player 1 has the standard selfish. Player 1 always only playing selfish. If always playing selfish, which one will we choose? Wait, I call someone. Nur Ain, Nabila? Okay, let's say player 1 for this particular matrix, they play selfish. They only play selfish. It means they only play which is the is there any Nash equilibrium for player 1 for this game? Or what is the highest payoff? Or what will be the selected payoff for player 1? For this one.
Tak ada.
Tak ada. For this one?
Tak ada juga.
Tak ada juga. Okay, thank you.
Okay.
Okay, let's say for this example, we have two types. We have player 1 only play one type, which is selfish. Player 2 can change their character or type between selfish and nice. Okay, if player 2 is selfish, then player 1 want to be selfish and choose D. But if player 2 is nice, player 1's best response is to play C or confess. So in this case, we have two types. But we did not know about which one will be chosen by them because of the incomplete information. So we will look of this particular method. I'm not going to finish all the lecture here today. I'm going to stop until here, okay? Because this will be a very you need to understand clearly what's going on the on the Bayesian game before you can start to deal with it. Okay, so what I'm going to do, I will stop until here. As long as you understand what means of the game, why we need to play a game, and what's good when we are playing an incomplete information of a game. Okay, So I'm going to stop here. I'm not going to sambung it because I want all of you focus on your test. Then we can start to continue a bit by a bit for every week. For next week. That's all. Anything you want to ask me until now? If no, thank you very much. We end the session.